Hey, welcome back everybody. I hope you're doing well at home. Hope you're kind of washing your hands, wearing a mask. I'm not going to wear a mask because I'm the only one in here because you guys are not here. So we're going to do, we kind of covered some of our basic trigonometry stuff. We talked about why trigonometry works. We did the sine, cosine, tangent for right triangles. We did inverse trig for right triangles. And we said, like, every time, again, I kind of use that word right triangles, right triangles, right triangles, because that's what our trigonometry is based around. But today we're going to show, well, I'm going to show you some magic of trigonometry where we can apply some of our sine and cosine to non-right triangles. That seems like that should be impossible because, again, sine, cosine, they really depend on having a similarity. They depend on having a right triangle. That's a really key part. But we can show how we can kind of sneak past that and make up some formulas that apply to non-right triangles. So we'll see what that looks like. But that's our goal. We're going to use trig to find sides and angles in non-right triangles, which should seem like a mystery to you because that really doesn't make sense based on what we've said. But we'll talk about why it works. First thing we'll do is we'll explain the law of sines, and then we'll do a little bit of practice. Again, I'll try and keep the video short, but I think I'll probably justify the law and then just do one practice problem together maybe. Okay. So the law of sines, this is what the law of sines is. It's this thing right here. Sine of angle A divided by A is equal to sine of B divided by side B. Sine of angle C divided by side C. So all those things are going to be equal. So if we look at our triangle here, if we take the sine of an angle, basically what it means is if we have any triangle, right triangle or non-right triangle, if we take the sine of an angle and divide it by its opposite side, that's going to be equal to any other sine of an angle divided by its opposite side. So we could use that to solve a problem maybe like this, where say we know B is, let's say 35 degrees, we know B is say 10, in this case we know angle C is say, hopefully you can see this over there, we'll say angle C is 25 degrees, and we want to find side C. So what we could do is say, well, the sine of 35, sine of angle B, divided by its opposite side, is going to be equal to the sine of 25 divided by its opposite side, which for us is going to be our x. Okay. From here we have, basically those are just numbers, right? Sine 35 is a number, sine of 25 is just a number. We can solve this to get x. So let's see, we do a little cross multiply. X times sine 35 is equal to 10 times sine 25. Get x by itself, we divide sine by 35, we get sine by 35. And we do a little cancel. X is going to be equal to that. I won't do the actual calculator bit, but we can figure out what that value actually is going to be just by entering it into your calculator, right? So that's why this is valuable. We could find a missing side, which we otherwise would have a hard time figuring out. Because again, this is not a right triangle. Angle A up there is not 90 degrees. We don't know what it is. Well, 35, 25, 60, so it should be like 120. Yeah, it doesn't look quite right there, but it's not a right angle anyways. Okay, so that's why this is useful. How can we prove that it works? So we're going to do a little bit trickery. We're going to do a little bit of magic to make this work. Law of sines. Basically what we're going to do is we're going to start with our triangle. It's a non-right triangle. And we're going to drop an altitude in there. You see that altitude H? It's right. Forms a right angle with side BC. Right? H with side BC. We can do this to explain why this formula is true. Bells are still working even though you're not here. Who knew? So what we need to do here is we have a right triangle here. Okay, now we can still do sine. So we can say sine of A is equal to opposite over hypotenuse. So nothing crazy there. Sine of A is H over C. Also we could say sine of C, still it's a right triangle, sine of C is going to be H over A. Okay. We don't really like that, so if we solve both of these for h, because we don't really like the fact there's an h in there, multiply both sides by c here. So h is equal to sine let's see, sine of A times C. And then down here we get h is equal to A times sine of C. Okay? So for top and bottom, they're both equal to h. So what's that magic word? Transitive, right? Both equal to h, so they're equal to each other. Sine of A times C is equal to A sine of C. Do a little bit of rearranging, divide both sides by A, divide both sides by A, divide both sides by, so these are cancel, cancel. Let's get rid of C, divide both sides by C, cancel, cancel. We get sine of A over A is equal to sine of C divided by C. So we used right triangles in order to get our equation. And we can apply this to a non-right triangle. We don't really need h to be in there. We can make an equation using h to figure out our equation. And now we have a rule that applies to a non-right triangle. Let's see if I have a good diagram for the next one. Okay. No. So what we can do here, but we're not quite done, because our goal is to show this thing. So we have like sine of A over A is sine of C over C. What we need to do is draw in one more, we're going to take the same diagram and I'm going to draw in a line, let's call this like this. And I'm going to call that line, it's going to be perpendicular still, and I'll call that line, I don't know, I feel like calling it L. So we're kind of going to ignore h for now. And what I can do here is say, okay, with my new line L, I kind of have to look at it sideways, but we still have a right triangle here and a right triangle here. So we could say sine of B, let's see, sine of B is going to be equal to opposite over hypotenuse. So sine of B is equal to L over A. Sine of, we're not going to do C now, we're going to do A. Still going. Sine of A is going to be L over B. If you remember where we got last time, at the end of our problem, we got sine of A over A is equal to sine of C over C. If we do a little bit of magic here again, L is equal to sine A times sine of B. L is equal to B times sine of A. Again, do a little, I'm not going to skip a step here, but I'll just show it, that's fine. A times sine of B is equal to B times sine of A. Divide both sides by A, B, cancel, cancel. Divide both sides by A, B, cancel, cancel. And we get sine of B over B is sine of A over A. Okay, so last time we get sine of A over A is equal to sine of C over C. Now we get sine of A over A is equal to sine of B over B. So again, transitive magic, we can show that all three of these things are going to be the same. Okay? So that's why law of sine works. And I think it's important to know why it works, because otherwise it seems crazy that we can apply this to a non-right triangle. But we kind of like, we're doing a little bit of work to make it so that even though our original triangle wasn't a right triangle, we can still kind of get this